All right, here we are in the machine. I just placed this this plate that I've made with T-slots on top of the pallet, and I wasn't too careful about it. And I want to make sure that they're running parallel to the actual machine zero on the machine. So I've loosened all the bolts, and I swing this indicator over here around on this middle set of T-slots until I get my 0 point the same on both sides. So I have to jog it upward out of the way, and then rotate around 180, jog it back down in Z, and swing the indicator over this set. And I've tapped it around. I've already done this. I've tapped it around until I got both of these to indicate the same on both sides. Now I have to tighten all the screws and check it again. It's important when you're doing this kind of thing to check it after you tighten things, because it could shift a little bit. This isn't really totally essential, because I could set the B-axis 0 and make up for this an error in this the angular displacement, I guess I'd say, of these T-slots, but because my fixture is lining up on two of these, whichever place I put it. But it would be easier, and I wouldn't be less problems when making the setups if it's right at 0 and 90 degrees and 270 degrees and 180, and I don't have to worry about that. I could just set the B-axis 0 point where I want it. So that's the reason I'm doing this. Putting it actually on machine 0, centered, and parallel or perpendicular to the axes, depending on which way I rotate this. Because most of our setups on these Anvils are going to be down with just the B-axis clamped. We're not going to do any kind of like rotary machine work here. Okay, let's check it to see. Doesn't look too bad. Okay, that side looks pretty good. After tightening the screws, let's rotate it around. Come back. I haven't moved the indicator. We're sitting on machine 0 in the X, by the way, here. That looks pretty good. Okay. Looks good. After tightening down. Now, let's, I'm not worried about this way because I can move the fixtures back and forth that way. And I can put it wherever I want. I can even move it to this set. These are all spaced the same, so I can move it over this way, or put it in the center. We're going to start out with it in the center. So let's get the block mounted on the fixture, and the fixture mounted on the machine back in here, and we'll line up on our fixture offset 0, and then make a program to rough out these 3 blocks from the forging. I may have miscalculated a little bit here on, can't get that nut started on there. I'm gonna have to lift the part back up with the crane so that I can get the nut between here, and then spin the nut down while I lower it down with the crane. Didn't allow really enough space in between here for this to go on. Okay, let me see, I gotta lift it up a little bit. Okay. How straight it is. I don't expect it's going to be perfectly straight. I think it's going to be tipped a little bit this way, because when I indicated this thing, when I was facing off the bottom of it, it wasn't perfectly square. A couple of thousandths. So I kind of expect this up and down direction. Let me zero this about right here. I expect this up and down position to be to be kind of a little bit out of square. Let's see how it looks this direction. Zero that again. It's not too bad. I could live with that. It's up and down, and we're just making an anvil. We're just doing roughing right at the moment. Kind of out about 5/1000, 6/1000 of an inch. Maybe even a little more. It doesn't surprise me, because when I indicated this, when I was facing the bottom face, I had it setting on one of these faces here, and it must have been a little bit out of square when it was setting right on the edge of this pallet face.
Okay, I want to jump in here a little bit. I was having a lot of trouble with this tool when I started with it. I've never really liked this feed. This is an ISCAR feed mill. I've never really liked it. It has too many inserts, I think, is the problem with it. It's got 5 inserts on an 1.5" diameter cutter. And I think on this kind of tool that puts too much pressure and causes chatter, and I was having a lot of difficulty with this tool. I couldn't get it to work. You may be hearing how terrible it sounds. Basically, it's so I was varying the feed rate and spindle speeds here. You might notice in the video the cutter looks like it's changing right there. See, because I'm trying to adjust the RPM and the feed rate, but I couldn't quiet this tool down. It was just having a lot of trouble with it, so I ran a few passes with it, and it obviously wasn't going to do it. So I decided to change to a different tool. Sometimes you have to do this. You just can't get. And this material is kind of tough too. This tool might work all right in you know, maybe a softer material or something. But this steel has got a little bit of a heat treat to it, and it's a pretty tough material. And also, I think I was taking a little bit too deep a depth of cut with this feed mill for this material. So I changed from this tool to the Mitsubishi feed mill that I have. That's about 1 inch. Well, it's 1.5" in diameter, but only has 3 inserts on it. And I tried the same parameters in the program, and you'll see here in a second. And it worked better, but then I actually stopped. You don't see it in the video because I kind of cut it out, but I stopped it, and then I changed the depth of cut and reduced the depth of cut, and I got it to work all right. So I ended up with the Mitsubishi feed mill running at 100 inches a minute at 800 RPM. See, here's where I'm taking the tool out because I'm saying it's just not going to cut it. And fortunately I did, because I'm going to show it to you here, and the inserts are all broken, or not all of them, but some of them are already broken. See? So this is the tool I changed to. And like I say, at my first running of the tool, I had the exact same cutting parameters that I was running on the ISCAR tool, and it was better. And I was trying to manipulate the feed and speed as well. And so I ran a couple of passes with this like that after I got into the material. The first part of this is just running air passes, so I sped it up real fast. And that starts here in a second, I think. And this is just air passes to get down to where I left off with the other tool. And then I started messing with the feeds and speeds at that point. And it was better. You can probably hear it. It's quite a bit better, but it wasn't. It still was not quite right, so I stopped it. And like I said, you can't see it in the video, but I stopped it and changed the program. And these tools, what they like to silence vibration and chatter is higher feed rates and lower speed with a higher feed rate, actually. So, like I say, the ultimate feed rate I came up with for this was 100 inches per minute at 800 RPM. And I think I had the program slowing it down when it's doing a full diameter cut to 60% of that feed, I think, if I remember right. And I also reduced the depth of cut. I could only really get this tool to quiet down at 25 thousandths depth of cut. I originally had 50 thousandths, so I had to reduce it to half. And then it started to behave, and I could just let it run. It wasn't a problem. And you'll see I stopped the tool further along in the video here when I was about 1 inch deep, and the inserts looked like they hadn't even really been used yet. And in fact, I roughed everything you see with this tool and didn't index the inserts. So I probably could have pushed it harder, but I didn't really want a chance messing the tool up. This is a 4340 steel, and it's got a little bit of a heat treat to it. It's a kind of tough material. So anyway, I wanted to mention that so you kind of understand what was happening.
Okay, I stopped it here just to take a look at the inserts and see how they look. We've already got about an inch deep into the cut. Look real good, no problem. Now we got to send it around and turn it around on this fixture here, and we'll mill through the other side here.
Alright, I think we're going to stop the video right about here because it's getting kind of long, and we're going to pick it up when we do the other side. And like I said in the previous video, we're just going to rough through, but we're going to leave attachment points, I guess you would say, on each the top and the bottom of the little anvils so that they don't fall off of there and land on the pallet or hit the way guards of the machine and dent the way guards, because they still weigh like about 50-ish pounds before they've been finished machined. I think they're going to weigh 46 pounds, if I remember, something 45 pounds when they're finished. So that's the first side of the roughing out of these anvils, and thanks for watching.